All right, guys, welcome to the first section of the first chapter of our statistics course. This is going to be 1.1. We're just going to kind of go over a lot of kind of basic definitions of things that we're going to be dealing with this entire year in our stats course. So to kind of start off here, I want to begin by just kind of going over these kind of terms that you're going to hear quite a bit throughout the entire year. The first one is just statistics, kind of what is it? So there's kind of four key components to statistics. It is kind of the collection, the organization, the analysis, and the interpretation of data. And that can come in a lot of different ways. And we are going to cover all four of those things in that particular order. This first section is a little bit of a kind of off-the-box thing because it's we're going to kind of cover all the basic definitions, and then we're going to go into the first thing, how we can collect data correctly. And then we're going to go over, once we've collected it, how can we organize it? Once we've organized it, how can we analyze it? And then once we've analyzed it, how can we interpret it? Like, what does it tell us? And those four things are done in that order for a very particular reason. If you do any of those things incorrectly, everything you do beyond it is effectively meaningless, right? If I collect bad data, it doesn't matter what I do with it as far as organizing and analyzing and interpreting it. It's not valid because I gathered bad data. So it's really important at every single step along the way that you're doing things correctly. So that's why we always kind of start with that first phase and then work our way through it throughout the entire year. So then by the end of the year, collection and organization, and then even part of the analysis part will be kind of second nature because you've done it so much. Right? Other main variables which you're going to see are individuals. That's going to be the things you're actually studying. That typically in English kind of makes you think people. It can be people, but it doesn't have to be. It could be objects. Say I'm measuring the amount of milk in milk jugs. The milk jugs are my individuals. Right? And then variable is the actual thing you are observing or measuring. It's the physical response or thing you are writing down from that, right? So again, with that milk jugs thing, it's the amount of milk is my variable in that kind of instance. If you're doing a survey of people, those people would be your individuals, and the responses they give you to that survey, those are the variables you are getting. And there's two types of variables. We can have either a quantitative variable. So quantitative, think quantity, or the amount of. So those are variables that are going to have some kind of numbered value to them. So like measuring people's heights, that's a quantitative variable, right? If I say, what's your favorite color, I can't prescribe some number to that. That actually makes sense and is meaningful. So that's going to be what's called a qualitative variable, which is the other one there, right? Those are things which are still responses, but there's not a numerical value to it. As you might expect, things that are quantitative, which give us that kind of numbered response, we can typically do a lot more with those. That doesn't mean that we only ever want quantitative stuff, but as far as numerical analysis, you can do a lot more of that than just the qualitative responses. Next thing here, we're going to talk about population data and sample data. So population data is data which you get from every single person in the entire population. Now, population is a term we haven't really formally defined yet, but it's basically the entire group that you're trying to actually study. So that could be everyone in the US. It could be everyone in the world. It could be, hey, everyone in your English class, right? Whatever you define that population as, every single person that is in that is your population. So if I gather data from every single one of those people, then I have what's called population data. If your population is fairly small, like, hey, it's my English class, you can get that fairly easily. But if it's larger, like, hey, everyone in the state of Idaho, or all adults in the US, it's nearly impossible to get that population data. So that's where we get what's called sample data. Now that's when we get data from some of those people in that population, and we kind of use that to estimate or infer what is true about the entirety of the population. That's kind of one of the main cruxes of statistics for us. So those are very closely related to what's called a parameter and a statistic. So a parameter is that data you get from the entire population. So let's say I measured the height of everyone in my English class. That I would have population data, and if I average that, that's a parameter. It's a population parameter because I got data from every single person in that particular population. Now, if I had my population be everyone in the entire school, and I just surveyed 7 different classes, that would be a sample statistic, right? Because I got it from just some people out of the entire population. So how you define that population matters on if you're going to have a population parameter or a sample statistic. Really, it's the exact same thing. It's a matter of, did you get it from everybody or just some people, right? Or individuals, they could be objects, not necessarily people, right? It's really easy to kind of keep those related, the P with the P, the S with the S, right? Population and parameter, sample and statistic, right? So those are kind of key terms here. We're going to be talking about statistics drastically more than we're going to be talking about parameters. That's kind of why it's called a statistics class, because if you have data from the entire population, that's just kind of, you have that data, you don't really need to do much else with it. But when you have a sample, so you get that statistic, you then want to use that to make inferences or estimates about what the entire population is doing. That's kind of one of the cruxes of what we do in this particular class. So as you're going to notice throughout the year, I'm going to give you a lot of these kind of real-world situations from actual studies, and then I'm going to kind of ask you some questions about that. So we're going to kind of work through this. So we have the Harris poll here, and that they surveyed 2,286 adults in the U.S., and they asked them if they agree or disagree with the following statement. Learning and habits from music education equip people to be better team players in their careers. So they said, hey, do you agree with this statement or do you disagree with this statement? And they found that 71% of the people they surveyed agreed with that particular statement. Now, I'm not trying to analyze, hey, what does this mean? It's just a real world thing. Now, tell me this, right? Identify the individuals and the variable in this particular study. So go ahead and pause. Once you have answered it to yourself, then hit play again, and that's kind of how these things work. Right? So the individuals here are going to be the adults that were surveyed. Right? It's all 2,286 of the adults in the actual survey. The variable, which is the answer we are getting, it's that actual response, the agree or disagree response to the survey, and that's typically what the variable is going to be. In this case, it's really hard to give it one nice, really clean name. It's the response to this particular question. If it was, say, their like height, then the variable is just what their height is, right? Next one here. Is this a sample or is it a population? So it's going to be a sample because we've kind of defined our population as adults in the US. Now, you're not always going to see things that explicitly say we are defining the population as blank, right? But here in their kind of wording, right, they are saying 2,286 adults within the US, right? So it's kind of implied, hey, they were adults in the US. That's our implied population, right? And you can typically safely assume that unless you are told otherwise. Right? So, is this a qualitative or a quantitative variable? Right? So again, our variable was their response of agree or disagree. So it's going to be a qualitative, right? Because we can't prescribe some numerical value to agree versus disagree. Now, what if we wanted some quantitative variables? So now there's a plethora here, but try and pick what are some variables which would give you a number in response that you might actually care about for this particular situation. Right? So again, there could be tons of like others. Two that I kind of picked out would be age and income of the person surveyed. You can have quantitative variables like, hey, how tall is the person? How many letters are in their last name, right? Those would all be quantitative variables, but are those things that we would care about in relation to this other question we asked them? Probably not. But what might? Well, maybe their age. If they're very, very old, maybe they think differently about this than people that are very, very young, and vice versa, right? Their income might play a role in that, or do the wealthy have a different view on how that's going to affect things versus those that are kind of on the poorer end of the actual spectrum. So all of those are things which could impact things which we could actually want to know in addition to that first question. So again, you could have any number of things there. Those are just some that I kind of picked out. All right, so then is this a statistic or a parameter? So again, we said that this was a sample, so it's going to be a statistic, right? If it was from the entirety of the population, like we got this data from literally every single adult in the US, which is basically impossible, then it would be a parameter, right? But since we only got it from a sample, it's going to be a statistic for us. Okay, so the next thing that we're going to be talking about here, and this is kind of the last main crux, is what's called levels of measurement. This is where it gets a little bit kind of wordy and particular. I'm going to kind of go over in general what each of them are, give you some examples, and then we'll kind of try some of these out to kind of see if you can pull them out on your own. Once you kind of get the process, it's not terribly difficult though, but it's kind of a new idea to kind of approach things. So we have what's called nominal, ordinal, interval, and ratio levels. Their formal names are the nominal level of measurement, the ordinal level of measurement, and so forth. We typically just say, hey, that's nominal, that's ordinal, that's interval, that's ratio. Now, starting at the top of this list here where it says nominal, that is the lowest level, right? So that is the kind of baseline. Everything is that or more, right? So this is the kind of base level, and then you might be higher to get here, higher to get here, and then the highest level would be ratio. So what nominal is nominal is any kind of data that is just names or labels or categories, right? There is no way for me to order things in any way that actually makes any kind of logical sense, right? Doing things in like alphabetical order doesn't count, right? So this would be things like, what city were you born in, right? I can't rank cities as like, well, Boise is higher than Nampa, which is higher than Caldwell, which is higher than Sun Valley, whatever, right? I can't do that, right? There's no logical way for me to order those things, right? So anything that is that kind of level, that's a nominal level of measurement, right? It's just that really base level kind of category stuff. Now the next step up is what's called ordinal level, right? So in this one, we can order it, right? And now there's two kind of caveats there. Now either the ordering is meaningless, or there's no distinct difference between the values in that actual order. Okay, so by meaningless, this would be things like think horses in a race, like they give each of those horses a number, right? Is the difference of horse number 1 to horse number 2, is there a difference there, like other than their like numbers? I could order them horse 1, horse 2, horse 3, horse 4, horse 5. That's me just kind of arbitrarily ordering those horses, right? So that's when the numbers kind of are meaningless. The other way that we could see that is maybe it is a thing that I can order, right? So you might be asked a question of, hey, rank this movie out of 10, right? Is it a 10 out of 10 movie? Is it a 5 out of 10 movie? Is it an 8 out of 10 movie? So something like that, right? So you might get all these different responses, and someone saying 10 out of 10 is better than say 9 out of 10. We can order those responses, and it makes sense. But here's the issue there. The difference between an 8 rating and a 9 rating is not measurably the same as the difference between a 9 rating and a 10 rating. Okay. You have to get past the number part of this and say, hey, is a movie that's an 8 to a 9, is that 9 movie as much better than the 8 movie as a 10 movie is from a 9 movie, right? It's once you kind of get what that's saying, it hopefully makes a little bit more sense. The other way that you can think of it is adding and subtracting those numbers here doesn't work now, right? So for example, right, is me watching a 10 out of 10 movie the same as me watching an 8 out of 10 movie and a 2 out of 10 movie? Watching those two back to back is just as good as watching a 10 out of 10 movie. No, that's not how ratings work, right? So that's why it's at that ordinal level. Like, we can't kind of add those numbers and get equivalent values out of it. Now the next level up from that is the interval level. And the change there is now that addition stuff will work, okay? So I can say, hey, the difference from this to this is the same, right? The catch here is that there's no true zero, okay? Effectively what that means is you can do addition and subtraction. Those things work kind of fine, but division and multiplication don't. And that's going to be what takes you up to the final level. Now, I want to talk a little bit more about interval level first before we go on to ratio. So interval would be, the easy one here is like the years, right? So think the year 2015, right? And then the year 2016. Is the difference from the year 2015 to the year 2016 the same as the difference between 2016 and 2017? Well, yeah, that's just a 1 year difference. That's makes sense, right? So addition kind of works there, right? All of that works, right? The problem is when we try and do things like multiplication. So think doubling, right? Is the year 2000 double the year 1000, right? Numerically, yes, but that's always the case, right? But time-wise, has as much time in general passed at the year 1000 as the year 2000? Well, no, right? That's because year 0 is not a true 0, right? Because we go before year 0, just because of how our year system works, right? There's that BCE time, right? Before the Common Era, all of that, right? So the 0 we use there is not a true 0, right? So interval is kind of that weird one, but the easy test for that is say, hey, does doubling work? And if so, then you're not interval, you're at ratio. But if doubling and having things doesn't work, then you're going to stay at that interval level. Now let's talk about ratio. Okay, so ratio is when that doubling and having things like that works, right? So let's talk about height one more time. It's a really easy one that I'm going to use all year long, but height's just a really easy thing to kind of measure in a sense. Okay, so for a person's height, if someone is 6 feet tall versus 5 feet tall, that's a 1 foot difference. That's the same difference of someone who is 4 feet tall to 5 feet tall, right? It's that same 1 foot difference, so definitely addition and subtraction works. So we're out of the ordinal level, we're up to the interval level. Now, does halving work, right? Is someone who's 3 feet tall half as tall as someone who's 6 feet tall? Well, yeah, right? That's half of the height. Likewise, someone who is 6 feet tall is twice as tall as someone who is 3 feet tall, right? That makes sense. So that says, hey, we're at the ratio level. Now, why that works is we have a true zero with height, right? You can't have a negative height, right? People can't be negative feet tall. That's not how height works, right? So that's why it pushes us to that ratio level. Now, another really nice one to kind of talk about the difference between interval and ratio is temperature. So let's say it's 70 degrees outside, right? Nice day. Is the difference between 70 degrees and 71 degrees the same as 71 and 72? Well, yeah, that's a measurable difference, and it's really just a measure of the amount of energy, and that works, right? So we're out of ordinal, we're up to the interval level at least. Now, can we have it or can we double it, right? Is 70 degrees twice as hot as 35 degrees? Now the answer is no. Numerically, 70 degrees is twice what 35 degrees is, but there's not double the amount of energy in that heat, because heat's really just a measure of light energy. I'm not going to get too much into the physics, but that's where it comes from. So we can't do that because there's not a true zero, and you kind of know that, right? When it goes down to 0 degrees Fahrenheit, it's not like that's as cold as it could possibly get, because we have negative degrees there, right? Negative degrees Fahrenheit is still some measure of like heat, right? So there's not that true zero which you can't go beyond. Same thing with Celsius, right? 0 is the temperature which water freezes, but we can go lower than that. So there's not a true zero with Celsius either. Now, if you are a physics person, you might already be kind of saying, but there is one which has a true zero, and that is correct, and that's where I'm going next. That is the Kelvin measurement. So Kelvin is basically Celsius, but it starts at true zero, right? So it has the absolute zero, which is the true zero, where there's zero energy, right? And then above that, you start to go 1 degrees, 2 degrees, 3 degrees. So temperature as measured in Kelvin is a ratio level measurement. Temperature measured in Celsius or Fahrenheit is an interval level of measurement. Now that's kind of my best way to explain the difference between interval and ratio. Those are the ones that people kind of have the hardest time with. So hopefully that addition and subtraction taking you to interval, multiplication and division taking you to ratio, explanation kind of makes sense. So with that, try this out. So I'm going to give you this situation, pause the video, try and answer those in as far as what level of measurement those all have. All right, now that we're back. So you could argue some of these, but I tried to pick ones that are fairly non-arguable. On a test though, if you put a good explanation as why you think it's that and you can kind of justify it, I would give it to you if it's not what I would give it. So first one here, the senator's name, that's a nominal, right? We can't order names in a way that makes sense. The senator's age, right? That's going to be ratio level, right? Someone who is 20 is twice as old as someone who is 10, right? We're at that ratio level where adding and multiplying works. Senator was elected in these years, right? That's going to be interval, again, because the difference between those years is consistent, so adding works, but having it doesn't, because in the year 2000 and the year 1000 is not a double in time. Right? The senator's taxable income, right? I wish mine was that high, but it's not. That's ratio, okay? Because again, your taxable income has that true zero, right? If I make $10,000, that's half of someone who makes $20,000, okay? And we have that true zero because you can't have an income that is negative. If you do, for some reason, you should really quit your job because it's not a very good job. Then we have, they were asked to choose strongly support, neutral, against, or strongly against. So this is going to be an ordinal level, right? Because we can order those. I can say strongly support is above support, which is above neutral, which is above against, which is above strongly against. I can order those. But is the difference in those different categories consistent, right? Is the difference of someone strongly supporting to supporting the same as someone supporting to being neutral? No, right? And that's going to be pretty common. It's near impossible for things that are categorical like this, there's no numbers, to get past that ordinal level, right? Number 6, their marital status is single. So again, that's going to be the nominal level, right? They're single, they're divorced, they're widowed, they're married, whatever, right? We can't order those in a best to least best way, right? And then the last one here, a website ranked them 7th in their record for voting on bills regarding education. So again, there's a ranking there. It's first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, whatever, right? So I can order those in a way which kind of makes sense. So we're off of the nominal up to the ordinal level, but I can't say, well, the person in first to second, that difference is the same as second to third, because that's not kind of how those rankings work, right? Think in a race, the person who gets first versus the person who gets second is not the same difference as the person who gets second to third. There might be different sizes of like gaps there, things like that. So ordinal is as far as we can go on that particular measure. All right, last thing here, we want to talk about just the types of statistics. So this is going to be pretty quick, but it's fairly important. We have what's called descriptive statistics. These are basically things that are just trying to summarize or organize or just kind of say, hey, here's the information, right? So I go and I gather the average height of every student in my 5th period class, and then there it is, here is my average height, right? I'm not trying to say this means anything, I'm saying, hey, here's what the data is. Then we have what's called inferential statistics. So this is when we actually try and take that data and try and say something from it. So say I get it from I get heights from my 5th period, heights from my 8th period, and then I say, there's no 8th period, 7th period, and say, hey, they're taller than them on average. I'm inferring things from that data that I got. And that's where you start to have more problems. It becomes easier to kind of do things incorrectly once you start to infer things. But again, my kind of goal this entire year is to show you the process we use in statistics to make sure we're not doing things incorrectly and kind of getting bad conclusions. So this is kind of a big info dump here. Hopefully that kind of made sense. Again, take notes as you need, to pause these videos as you need. Our homework for this 1.1 section is going to be problems 1 through 4 and then problems 5 through 13's, the odds. And again, the odd answers are in the back of the book, so make sure you're checking those as you go through and do them. So with that, see you guys next time.